Assalamu alaikum. Hello, good evening, Dr. Roslin. Uh, First of all, I would like to say thank Allah for success of my project until this moment. I already finished everything related for the my implementation and results. And now I will update you, inshallah, by next week. Uh, the updates in the chapter 2 and 3 for research methodology, and I will complete my report regarding to the chapter 4 and 5, inshallah. So by making this video, I'll give you a brief run throughout the machine learning workflow. So now I'll show you here. This is my account for the GitHub. I already push my every single file for coding here. So now I will talking about the building data set. I already opened it here in new tab. So now I'll show you the type of data set. Yes, the first thing is building dataset to train our text classifier. I have built synthetic training set that is consists of emails here, as you can see, clean emails and gibberish language below. This is the type of gibberish languages, as you can see here, and English word list from Google, 10,000 most frequent word list here. Here, as you see here, this one, and the last one is Amazon reviews type of data set here. So all of this at the end our data set, and the data set will be basically have in two classes, which is dirty data and clean data. This is the type of class for the clean data class, and the second class for dirty data class here. After building the data set, okay, now I'll show you. I have experimented with a few machine learning algorithms, which is the features engineering, as you can see here. In the feature engineering that I have used are the options that I have all of this, okay, all of these options, but I only experimented with the count vector features and TF, this one and this one, algorithms, two types of algorithms. Yeah, the TF IDF vectors as the features, it has three types as you can see here, the word level and n-gram level, and the number 3 is character level. So I have only experimented this all. Here it will be how I generate the count vector as the features, and this is the more explanation about the TF-IDF features, as you see. So the TF-IDF basically represents the relative importance of the term in the documents. After generating the three types of TF-IDF, I have word level TF-IDF here. As you see, this is means 1 gram or unigram, and this is the n-gram, which means is the more of 2 grams and 3 grams of words. That means it will have represent the data, the text in more than one word, and that gives the higher chance for our work. And here the last one, the third one, we have the character level, the TF-IDF, but the character level TF-IDF is not really good because it looks into characters, and using character we not always able to see if a complete sentence is dirty or clean. I have also used the word embedding here, as you see. All this part about the feature engineering, which means the 2.3, which means the features machine is 2, then 2.1, 2.2, 2.3. This is the features name file. Then next, in the model building, I have experimented. So here you see the model build. I have experimented with 3 different algorithms, which is the naive Bayes. In the naive Bayes, we can see that the performance is not very good. It overfits the count vector, and here down in this results is not very good. It overfits the count vector, and with the word level TF-IDF achieved 88% accuracy, as you see, and the count vector is 100%. Also here in the word level TF-IDF 88%. Also the last one in the n-gram is vectors. N-gram vectors is 75%. So here next the second algorithm, linear classifier. And the linear classifier, it is good, its performance is high, but it seems to be overfitting because always near 100% in all the 3 features, as you can see. Here if you see here, all this is the 100%, and this is the 99 for word level, and the last one n-gram, the vector 97. So here finally, when I tested the support vector machine here, the VM on the n-gram level vector machine classifier in n-gram level TF-IDF vector. It gives us a better performance. It does not overfit and it maintains the high accuracy in the same time. I mean here. Well, this the file. This was our experimented. We only see the result here. I have built this support vector machine model and I tested in all three types of TF-IDF features here as you see. So the first TF-IDF features, which is the word level TF-IDF, and unfortunately the model is actually overfitting. The performance is 100%. It is not good, as you see here in the results here. 100 here, 100% for any gram. So, but then when I tested in the n-gram here, n-gram level, the TF-IDF, which means I tested on the features that more than one word to be 2 and 3 words. The model is persistent and the performance is 99. It also performs on the same level when I check for the clean testing. Here an example. Here I will show you an example. When we write something like this, I want to study postgraduate in the United Kingdom. The model actually predicts this clean text, but if we wrote like this type of language, okay, the model will predict this dirty text, which means the correct classifications. Then here in this final step, I just export the model artifacts and recognizer because I want to use them in our application. So the cleaning model here is basically the framework of the machine learning. It actually reads the model of artifacts that I have trained the value on. I mean here before the class, and inside this class, D class, it actually performs all types of the functions that we are interested in. Here the last file, which is the clean dash, this one, this is our main applications. This is our dash application, and it is what integration the front end and the back end to power the model that we are using here. I'll show you the whole code. Actually the perfect work doctor. I will explain everything inshallah in my reports for results and implementation. and conclusion. So this is the last one. Yes. Well, here I have built these applications called dclean, which is basically to automatically cleaning the data and detect dirty data in text e-business communication. I have used a web framework. Dash Enterprise is the best framework actually to deliver machine learning and data science initiatives. Most of companies, of largest companies, operationalize machine learning and data science models to rapidly real result. Uh, this Dash actually based on the Python language. So what you are seeing here in this page, we have four tags. At the first tag, or at the first phase, basically a demo that how can we detect a simple text here. For example, if I show you this type of text here, wait, we will copy these definitions for information technology and we'll paste it here, and now we will click on this button to know if this dirty text or clean. You see here, well, clean text. So now I will show you the second type of text. This is like the gibberish language. We'll copy all of this and paste it here. And we'll click here in this button to know now this is the result for the previous text. Now as you can see, this is the dirty text. Okay. It's basically in the back end, it uses this our machine learning model that I have trained before. So here it can detect the single sentence. For first phase, this is the first phase. But what if we have we are in the business and we have Excel file. It has a column of text and we want to detect which one is dirty text or which one is clean text. For that we can use this three phases, 1 and 2 and 3. So in this phase number 1, we need to upload and process the data. So for example, if we uploading here from this, select the file. Now we will upload the file for Excel types, for example this type of machine, and we will click. Now is uploading the file. Okay, here we have two columns, so it will upload and process the data, and then it will display them here. And if we are looking for into detecting one of these column, we go to phase 2 now. Yes, and we will process the file. Then select which is the column that we want to detect. Here press this button, and as you see here, we select which the column that we want to detect. For example, if we click on this button, assuming that we want to looking for this machine text, for example, and on phase 2 here, we will detect all the data on this button detect, and now it is done. So it has detected every single value in the column category. We will click on this button like this. As you see here, the detection is complete for the column machine text. Now we can go to the face tree. In this face, we have we can know, or if we that we can get the clean file. We can go direct to this button for the clean file, which means it have the removed the rules that include the dirty data. So when we press here, it will be generate the file. We can download it in automatically in our laptop here. When we click like this, as you can see here, you can press here, and as you see here, the clean file will be already here uploaded. Okay. But sometimes maybe we are interested to looking into annotation. We want to know which data is clean, which data is dirty here. For that, we can press here to prepare the annotated file, and the application will prepare the file for us, and we can download it from here throughout this button. Click just like this, and you can get the file from here. As you can see here, the file already finished. So thank you so much. Inshallah, hope you understand, doctor, and I ask Allah, inshallah, to pass us from this project, inshallah. Thank you so much. Assalamu alaikum wa rahmatullah.